In this webinar, I would like to review quickly the technology and applications of the NanoFrazor, explain you the important components of the hardware, show you the NanoFrazor software, then compare the different systems of the NanoFrazor. At the end, I will also introduce you some useful accessories. The standard approach for NanoFrazor lithography is using the hot tip to untip the thermosensitive resist material and write the nanostructures directly in the resistor. Due to the tiny tip and no proximity effect, you can write high-resolution, high-density patterns. After the pattern is written in the resistor, you can transfer it in many different ways. For example, etching, lift-off, nano-imprint lithography, etc. In this review paper, you will find more information. With hot tip, we can write pattern down to 10 nanometer resolution. With cold tip, we read out the topography of the written pattern. With the closed loop, we can control the patterning depth within single nanometer resolution. NanoFrazor is 1,000 times faster than other FM lithography technology. In addition, we use laser to thermally sublimate resist material and generate structures in the resistor. Laser is around 100 times faster than the tip. With NanoFrazor, you can prototype your new devices much faster due to in-situ inspection. If there's a mistake, you can see it immediately already during the patterning. There are also several unique opportunities beyond the usual nanolithography. For example, you can make 3D grayscale nanolithography with single nanometer resolution, and your sample is safe, will not be damaged by charged particles, and you can convert the material with a hot tip and explore more experiments in material science. Till now, we have more than 25 NanoFrazor systems installed worldwide, and a few more systems are waiting for the installation. Some of our users are using the NanoFrazor in their own group lab, but some NanoFrazor systems are installed inside a shared cleanroom facility. What all our customers like is that the installation is quite easy and can be done within 1 day, and almost all the labs can meet the vibration control standard VCB easily. Now let's look at the NanoFrazor hardware. Thermal cantilevers is the heart of the NanoFrazor. The cantilever is made of silicon, originally developed at IBM and now manufactured in MEMS foundry. The ultra-sharp tip has a radius smaller than 10 nanometer. We observed also tips with 2 nanometer radius as shown in this TEM image. There is a heater on the backside of the tip. It can be heated up to 1100 degrees. There's an integrated actuator, can move the tip up and down at the resolution of 1 nanometer. Next to the tip, there is a topography sensor, can sense the distance between the tip and the substrate at the 0.5 nanometer resolution. Cantilever is mounted on the cantilever holder. Cantilever holder provides reliable electrical contacts to the cantilever. In this video, you will see that cantilever exchange is quite easy, can be done within 1 minute. You can use the tweezer to pick up the cantilever and mount it on the holder. Then you bring the holder close to the scanner. The holder is fixed exactly at the right position on the scanner by magnetic force. The holder provides a stable position of your cantilever on top of your sample. The cantilever holder is connected to the low-noise analog electronics to control the tip heater, actuation, and read in the topography sensor signals. There is a real-time controller between PC and analog electronics to send out the command from PC and read in the signals of analog electronics. There are programmable processors and microcontrollers used in the real-time controller. To move the cantilever against the sample, we use high-speed piezo scanners. with high stiffness and low nonlinearity. There is accurate and fast sensors integrated to detect the exact position of the cantilever. With NanoFrazor, you can use almost any kind of substrate materials and various sample sizes up to 20 mm thick. For example, you can use a wafer holder for 4-inch silicon wafer and a special designed sample holder for crystal prism. Underneath the piezo scanner, we use the ultra-flat granite table to ensure the scanner performance. The granite table is very heavy to decouple the vibration from the environment. There's always vibration isolation integrated in the NanoFrazor system, either passive or active. To move the cantilever to any position on top of the sample, we use a long-range positioning system with high rigidity and straightness. It moves at a reasonable speed, around 20 mm per second, and nanometer resolution. To align the sample to the cantilever, we use the optical microscope. It has a view field of 1 mm times 1 mm with long working distance larger than 30 mm, which provides a good space if you need to work with very thick samples. All the hardware components are enclosed in the housing to protect them from acoustic noise, dust, and so on. We can put all the hardwares and electronics in one housing or separate them into 2 housings. With the Explore, you can pattern under different gas environment, for example, nitrogen or argon. The gas flow and the humidity monitoring inside the environment box is managed by the software. The laser write module uses the same light path as the optical microscope. We use a fiber laser at the wavelength of 405 nanometer and maximum power of 300 milliwatt. The laser focuses automatically on the sample surface. Now I want to show you the NanoFrazor software, which makes the hardware working properly. The NanoFrazor software is dedicated on NanoFrazor real-time controllers to achieve high-resolution 2D and 3D patterning. It has an intuitive graphic user interface for beginners to start easily and flexible for advanced users to fine-tuning their settings. You can also use scripting to automate your patterning process. For example, if you have a big structure to be patterned overnight. If you need any support on using the software, there is a comprehensive user manual integrated. You can also operate the machine from home or outside the lab through the remote control. We will continuously improve and extend the software, and we will share the updates with you for free. Newly, you can also upgrade the 3D software package later if you don't need it at the moment, for example, to fabricate your 2D material device. Next, I will demonstrate how to start your first NanoFrazor patterning with a video. Felix helped with the video and the explanation.
Okay, I just put in a new cantilever. That's this black chip here on top of a PPA coated sample. You move around here with your cursors, with your core stage to go to the location you want. And I set up already the database path where all the data will be saved, and then I press this green button for starting the calibration of this new cantilever. That's the temperature calibration. It's already done. It's doing some more calibration. If you want, you can look at all of them here in these advanced tools. Maybe approach is one of the common ones. But while it's doing these calibrations, we start loading already our layout. So we take these spiral faceplates, different gray values, and pixel size is now here 40 nanometer. They will be patterned between 15 and 45 nanometer deep. Can go here and we can actually repeat this field multiple times. We just select here, repeating it 3 times, this field. And then we go to our session window and press the green button, and off it goes, starting these patterning of these three fields. First, it's doing again, of course, some calibrations. It takes some time, so it's doing an approach, finding the surface again, and calibrating the scanners. You can check the default parameters here for the temperature and so on. There are a lot of advanced settings, but usually you don't need to worry about them. You just need the CLL runtime window here. And yeah, now it's starting. So it's writing and reading. So moving to the right, it's removing resist, and backwards, it's imaging the topography. And you can zoom in here and see here's a dirt particle, and also the first lines don't look perfect. That's because the parameters need to be found by our closed loop algorithm. So that's why always from the first pattern, the few first lines are not perfect. Okay, we can analyze it, we can look at it in the 3D view, but for checking it in real, better do a cross-section. Let's look at the central one, for example, here. And you see the red stuff, that's the target one, and the blue, the real test, and looks quite good. But here in the error map, you see the beginning was not, as I mentioned, not perfect. But let's see, it started with second field, should be much better, and indeed, it took the right values now, and it looks, from by eye, it looks quite good. Let's look at the cross-section. Yeah, it's matching very well with what it should write. Okay, maybe in the meantime, I show you some other things here. That's the utility window. In the Explore system, we have much more here, like with a laser and so on. But here you have a few settings. You can look at the microscope. Interesting thing is with scripting, that's kind of new. You can record what you do with your mouse and then write your own programs with the NanoFrazor, what you want to do. We have a very extensive help function here with on all the different functions and parameters, which is very helpful, in particular if you want to do some programming. We have also something on the processing help. This you can find here, and we log everything for support also. Yeah, but I see just the third field is also almost finished. So let's look at the session again. And here we click on the world map. So here you have an overview on all the patterns you do. So in the end, you will have a big AFM image. Yeah, but that's it. That's how you do your first pattern, and then you can go on.
Now I would like to demonstrate you how overlay contacts onto random nanowires. Suppose you have nanowires randomly spread on your substrate. You inspect the sample first with the integrated NanoFrazor AFM function. After select the nanowire you want to contact, you move the contact design to the position of the nanowire. It's possible to prepare the design and import them in the layout in advance. You can also rotate the layout to fit better the orientation of your nanowire. Then fine-tuning the position of the contacts design on the nanowire. If you are happy with everything, then you can start with the patterning. If you have a large structure, the software will split it into small fields, then pattern and stitching them together. You can choose fast or accurate stitching with in-situ imaging based on your fabrication requirements. We have a separate webinar about overlay and stitching. Now I would like to show you the NanoFrazor systems and their special features. The NanoFrazor Scholar is an entry-level tabletop NanoFrazor system, which is affordable for a single research group. NanoFrazor Explore is our first produced and delivered system of the company, which is also the first hybrid mix-match nanolithography tool. Explore is often installed in a multi-user facility. NanoFrazor Professional is targeted for industry automated manufacturing. The NanoFrazor Scholar has a separated housing for the writing head and the electronics. It can pattern the sample as large as 50 mm times 50 mm in size. Before our customer can prepare their own vibration isolation by themselves, now we always include an active vibration isolation in the system. The Scholar is less robust against acoustic noise compared to Explore to be able to work properly and achieve all the specifications. The noise level in the lab should be less than 40 dB. Due to the small footprint, Some of our customers are using the Scholar inside their glove box to protect their environment-sensitive materials. We developed a NanoFrazor glove box together with the membrane to provide extra mechanical stability. The optimized feed-through panel ensures a safe and sealed cabling. If you have a wish to customize your NanoFrazor glove box for your applications, please don't hesitate to discuss with us. NanoFrazor Explore can pattern as large as 100 mm times 100 mm size of sample. It has one housing for writing head, electronics, and vibration isolation. There is a small compartment to keep your gas bottle to provide the gas flow for the environment box. The housing provides a very good acoustic isolation. As soon as the acoustic noise in your lab is less than 60 dB, Explore can properly operate. There are only two cables coming out of the system. One is the power cable and the other is a signal cable to the computer. The laser write module DLS is integrated in the Explore, but it can be also upgraded later. Soon we will also have the multi-tip add-on available for the Explore. The next delivered Explore will be in new red and white corporate design. The mix and match lithography is an attractive feature of Explore. On the same substrate and the same resist material, anytime you can decide whether to pattern with laser or with hot tip. With laser, you can increase the throughput for microfeatures 100 times. You can always inspect the laser written features using NanoFrazor AF imaging. Then align the next pattern design exactly to the existing structure. If you have a larger structure, the software split it into small fields, then pattern and stitching them together automatically. The DLS module is designed by our mother company, Heidelberg Instruments Germany. We use a fiber laser at wavelengths of 405 nanometer. The laser patterning has a resolution better than 1 micrometer. There's a laser safety interlock, switch off the laser power as soon as the environment box is open. The video shows the patterning of a Heidelberg logo with laser. After the patterning is finished, the written pattern moves to the position of the tip to continue with the tip patterning. The DOS is operated in the NanoFrazor software. The laser focused automatically on the sample surface. Combining the NanoFrazor F imaging, we can calibrate the power automatically to achieve the best patterning result. The offset of tip laser position is calibrated automatically to ensure the easy and accurate overlay between the laser and the NanoFrazor written structures. When you import your layout design, you can decide whether to pattern with the laser or with the NanoFrazor, or partially by laser and partially by the NanoFrazor. The layout will be split into fields with the scanner range. All the fields are patterned by laser and NanoFrazor together, then stitched together automatically. The idea of a multi-tip extension for Explore is to pattern with the 10 cantilevers in parallel to increase the throughput. At the moment, we can control each cantilever in the array individually. It already saves the time for cantilever exchange. You can also decide to pattern with a sharp tip or blunt tip in the array for small or big structures. We plan to test the multi-tip extension this year. If you are interested to be the beta site, please contact us. Now let's have a look at the specifications of both Scholar and Explore systems side by side. Scholar is more sensitive to the environmental noise, therefore slightly worse numbers. The write speed of Scholar is also slower than the Explore. The minimum structure size of Scholar is specified as 20 nanometer, but you can also write 10 nanometer if you have quiet environment, because the minimum structure size is rather related to the tip dimensions. With the laser, we are able to demonstrate the minimum structure size of 600 nanometer. NanoFrazor Professional is designed for much larger sample size, up to 8-inch wafer, with better laser writer and multi-tip modules. There are a lot of automation planned for this system. We can customize and optimize the system for customers to meet their individual requirements of the applications. There are many useful accessories for NanoFrazor systems. The cantilever starts already below 50 Swiss francs per lever. We prepared the recipe book to share experience with our customers. Here you can find very detailed information about the resistor and pattern transfer process and more. We deliver also a start kit with PPA and all the tools needed to help our customer with an easy and reliable start. Kits are offered for various pattern transfer process, so that you don't need to organize all the small items by yourself. We support our customers not only on the patterning with NanoFrazor, but also on the sample preparation and the pattern transfer. We offer different levels of the support package so that we can focus our time and efforts to help our customers on developing their own process for their applications more efficiently. The warranty extensions are available as well. 20% discount is offered when the above items are purchased with the machine together. To summarize, I explained you all the smart design and high-quality components of NanoFrazor. I showed you the intuitive and flexible software. There are different NanoFrazor systems to fit all budgets and applications. We offer useful accessories for our customer to use the NanoFrazor more efficiently. We are always happy to support our customer on developing their own fabrication process. Thank you for your attention. You are welcome to join our thermal probe workshop, which is postponed for 1 year to November next year, or subscribe our magazine, The Lithographer.